a relevant thing of if you're teaching math, you probably should know some of the history of mathematics. Well, we are back at it with more on math. Not going to be ranting about anything this particular time, but I am going to be talking about the history of math. And just as a reminder, because this is going to come up again in the next video too that I'm going to do, math. Well, or in another video. I don't quite know if it'll be the next video, but we're going to try. Mathematics is the gate and the key of the sciences. Neglect of mathematics works injury to all knowledge, since he who is ignorant of it cannot know the other sciences or things of this world. And what is worse, men who are thus ignorant are unable to perceive their own ignorance, and so do not seek a remedy. Roger Bacon, the very wise Roger Bacon, one of the many along the evolution of science. Here, and he pointed out that mathematics is an important thing. So what I'm going to get into today is a little bit of the history of math, as nicely summarized, because it is a long and complex history, but thankfully a couple of different resources made a nice summary of the history of math. First, I'd just like to point out, check it out, we're on Locals now with Shio Sophia, so if you'd like to come in over here and chat, the way Locals works is that you can be a member of any community for free and kind of lurk and just see. But but the thing is, it doesn't let you engage with the community. It doesn't let you talk with others. You can't post. You can't comment if you're just a free member. But if you become a supporter of someone's community, paying a little bit per month or a little bit per year, you get access to everything in that community. You get to chat with the whole group of folks who are there. You also support things that I'm doing here. Thank you very much. But also, get to just have a good old time talking with us behind the scenes about science and not having to worry about censorship online. You can give monthly, you can give annual, and by the way, you get 2 months for free if you go annual, but it is there for you as an option here. So I hope you come over and join us on Locals. It's going to be a fun time. Anyway, back to Roger Bacon. And on to the history of math, but before we get to the history of math, what is math, actually? Mathematics. Mathematics, as from the Encyclopedia Britannica. The science of structure, order, and relation that has evolved from elemental practices of counting, measuring, and describing the shapes of objects. It deals with logical reasoning and quantitative calculation. Keynote, logical reasoning and quantitative calculation. And its development has involved an increasing degree of idealization and abstraction of its subject matter. Since the 17th century, mathematics has been an indispensable adjunct to the physical sciences and technology, and in more recent times it has assumed a similar role in the quantitative aspects of life sciences. In many cultures, under the stimulus of the needs of practical pursuits such as commerce and agriculture, mathematics has developed far beyond basic counting. This growth has been greatest in societies complex enough to sustain these activities and to provide leisure for contemplation and the opportunity to build on the achievements of earlier mathematicians. So, all mathematical systems, for example Euclidean geometry, are combinations of sets of axioms and theorems that can be logically deduced from the axioms. Inquiries into the logical and philosophical basis of mathematics reduce to questions of whether axioms of a given system ensure its completeness and its consistency. For full treatment, see Mathematics Foundations of. So, important thing to notice about mathematics is there is what we call the applied mathematics, which is to say mathematics being used for other things, and the more theoretical mathematics, which is where they develop new axioms and theorems and things along that line that advance the science of math, as it were, in here. So oftentimes when you're talking about mathematics in other fields, it is the applied version. You know, different things in statistics, physics, climate, chemistry, the whole works on down the lines, and in the life sciences now too, that is the applied aspect of math. But you still must know the basic fundamentals of math and other things. You're not developing new theorems of math most of the time. In here, you're not developing new theorems or axioms if you're doing the applied side, working in sciences or what have you, but you are applying mathematics at a very to a very high level if you're in some of the most complex fields of physical sciences or even in the life sciences now, and indeed sometimes also in the social sciences, depending upon what kinds of analysis you're doing, because you have statistics there, and statistics makes use of math. Anyway, with that in mind, we want to get to the history, and thankfully, through a combination of this particular website and Precedent, which has the history of mathematics in a handy timeline, as far as we know it, alongside of the, what do you know, the story of mathematics from its roots in Mesopotamia to the current history. So this actually provides a lot more detail in here, but much of the same much of the same kinds of things in here with the story of mathematics involved in here. But we can also go on to the history in short order here. So the earliest known kinds of forms of mathematics do come to us from Egypt. Which, by the way, don't forget what goes along there with the scientific method. The Edwin Smith papyrus, dated 1600 BC, is also from Egypt, actually, and is believed to cite an earlier textbook. The Edwin Smith papyrus shows us the history of. Not the history, but it shows us one of the earliest versions of what we now know as the modern scientific method. So yes, it's there in ancient days, well before Western Europe ever existed. You have things like math and science, or some variations thereof that we would now recognize as math and science. The early Egyptians settled in the fertile Nile Valley as about 6,000 BC, and they began to record patterns of lunar phases and the seasons, both for agricultural and religious reasons. Written numbers. It is thought the Egyptians introduced the earliest fully developed base of 10 numeration system at least as early as 2700 BC, and probably much earlier. Typo. Written numbers use a stroke for units, a heel bone for tens, and a coil of rope for hundreds, and a lotus plant for thousands, as well as hieroglyphic symbols for higher powers up to 10 up to a million. So yeah, you can see the different symbols that they think in here. The oldest mathematical text in ancient Egypt. The oldest mathematical text from ancient Egypt discovered so far, though, is the Moscow papyrus, which dates from the Egyptian Middle Kingdom 2000 to 1800 BC. So, early days of math, really, when you're getting into it. And actually, I want to go find it real quick. Yep, here it is. Oh, Moscow. Ha! One of them's not spelling it very well. Oldest known mathematical text discovered here. The pharaoh surveyors used measurements based on body parts. Ooh. A palm was the width of the hand to measure land and buildings very early in Egyptian history, and a decimal numeric system was developed based on our 10 fingers. Remember your tenths, hundredths, and what have you that you learned? It is thought that Egyptians introduced the earliest fully developed base 10 numeration system as early as 2700 BC, and probably much earlier. Written numbers used a stroke for units. Yes, here. The Rind papyrus, dating from 1650 BC, is a kind of instruction manual in arithmetic and geometry. So, multiplication. Look at that. Has to do with multiplication right here. 2 multiply 3 by 6. Has to do with that. In here, let's see, also contains evidence of other mathematical knowledge, including unit fractions, composite and prime numbers, arithmetic, geometric and harmonic means, and how to solve first-order linear equations, as well as arithmetic and geometric series. The Berlin papyrus, which dates from around 1300 BC, shows that ancient Egyptians could solve separate second-order algebraic or quadratic equations, and before they ever had graphing calculators. Or computers, for that matter. They were solving these things. Think about that one before you complain on a math problem, yeah? Multiplication, unit fractions. The Egyptians approximated the area of a circle by using shapes whose area they did know. They observed that the area of a circle of a diameter of 9 units, for example, was very close to the area of a square with sides of 8 units, so that the area of circles of other diameters could be obtained by multiplying by the diameter multiplying the diameter by 8/9 and then squaring it. This gives an effective approximation of pi, accurate to within less than 1%. Very accurate. Pyramids are another indication of the sophistication of Egyptian mathematics, setting aside claims that the pyramids are the first known structures to observe the golden ratio of 1 to 1.618. There is certainly evidence that they knew the formula for the volume of a pyramid: 1/3 times the height, 1/3 times the height times the length times the width, as well as of a truncated or clipped pyramid. They were also aware, long before Pythagoras, of the rule that a triangle with sides of 3, 4, and 5 units yields a perfect right triangle, and Egyptian builders use knotted ropes at intervals of 3, 4, and 5 units in order to ensure exact right angles for their stonework. In fact, 3, 4, 5 triangle is often called Egyptian. Hey, something interesting you learn, right? Going on. Other places we find them, of course, this is well before we get to the Greeks even, many mathematical tablets in Babylon, Babylonia, which is Middle East. Would be modern-day Middle East. Many of the mathematical tablets are problem texts. They contain problems or sets of problems, sometimes with solutions. Many of the problems involve geometry. The rest are almost always word problems, where the context is the area of the calculation of an irregular field, the volume of a ditch, the number of bricks to build a ramp, etc. Early Chinese simple mathematics on oracle bone script date back to the Shang Dynasty, 1600 to 1050 BC. One of the oldest surviving mathematical works is the Yi Jing, which greatly influenced written literature during the Zhou Dynasty. I probably butchered the pronunciation, I apologize. For mathematics, the book included a sophisticated use of hexagrams. Leibniz pointed out the I Ching contained elements of binary numbers. When you're working with different number systems, the standard that everybody deals with, in the US at least, is base 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But of course, binaries are ones and zeros, and that's your base there. And then there's other systems that are base 60. For instance, I think they had an example in here. God damn it, stupid ads. Yeah, so the Sumerian Babylonian number system of the ancient days was base 60, actually, rather than base 10. So you would go for 1 through 60, and then you would go beyond that. Yeah. It has been conjectured. Yeah, 60 has many divisors, more than 10 does. So that's one of the reasons there that sometimes makes it interesting. Yes, they were the first ones also to have something for 0, interestingly enough, in the Babylon. But there's an awful lot here, so that's why I'm kind of doing the summarized Cliff Notes version for you. There's an awful lot to the history of mathematics, just as much as there's an awful lot to the history of science, or the history of the scientific method anyway. India, another place. Mantras from the early Vedic period invoke powers of 10 from 100 all the way up to 1,000,000,000,000 and provide evidence of the use of arithmetic operations such as addition, subtraction, multiplication, fractions, squares, cubes, and roots. Math and history. Then, of course, we get to the classical Greek. Historians traditionally place the beginning of Greek mathematics proper to the age of Telos in Miletus. Little note, I probably butchered that pronunciation too. This is where it gets interesting reading the historical, because I am going to butcher the pronunciation many times. Little is known about the life and work of Thales, so little indeed that the date of his birth and death are estimated from the eclipse of 585 BC, which probably occurred while he was in his prime. Despite this, it is generally agreed that Thales is the first of the 7 wise men of Greece. The 2 earliest mathematical theorems, Thales' theorem and intercept theorem, are attributed to Thales. Thales is also thought to be the earliest known man in history to whom specific mathematical discoveries have been attributed, although it is not known whether or not Thales was the one who introduced into mathematics the logical structure that is so ubiquitous today. It is known that within 200 years of Thales, the Greeks had introduced a logical structure, the idea of proof, into mathematics. Most of the mathematical texts written in Greek have been found in Greece, Asia Minor, Egypt, Mesopotamia, and Sicily. This is the Hellenistic mathematics. Babylonian mathematics again. Babylonian mathematics, also known as Assyro-Babylonian mathematics, was any mathematics developed or practiced by the people of Mesopotamia from the days of the early Sumerians to the fall of Babylon in 539 BC. Babylonian mathematical texts are plentiful and well edited. Let's see. In the Hellenistic period. So all of this, well ahead of Europe, for the most part, with the exception, these are all ancient Greeks by our standards today in here, but there was a huge amount of math that developed India, China, Greece, Babylon, Egypt, the whole ball of wax, and much like the scientific method, the ancient world gave birth to a lot of things, and it is decidedly not just Western. None of this is just Western. And I'm sure there are many different ways that multiple civilizations in different parts of the world, be it from North America to South America to Africa to Australia, had different ways of counting and doing math. And that's true. But mathematics itself is not a discipline that is solely just Western or European. And from its very earliest ancient days, it is not that. Let's see here. Oh, yeah. European Middle Ages, when Chinese, Islamic, and Indian mathematicians had been in ascendancy and Europe fell into the Dark Ages, almost all mathematical and intellectual endeavors stagnated. So this is the Dark Ages of Europe. After the fall of the Roman Empire and the Byzantine Empire. No, the Byzantine Empire lasted a little bit longer, but after the fall of the Roman Empire, for sure, here, everything went backwards in Europe for a good while. And the Renaissance in Europe happened quite a bit after the Renaissance of multiple other areas of the world, and particularly the Middle East and, India and China and what have you. So yeah, Indian mathematics. In the classical period of Indian mathematics from 400 to 1600, important contributions were made by scholars like, I'm not going to be able to pronounce that. Oh, goodness. The decimal number system in worldwide use today was first recorded in Indian mathematics. Tenths, hundredths, thousandths, that decimal system that we use? India. Very much in India. Golden Age Indian mathematics made fundamental advances in the theory of trigonometry, a method linking geometry and numbers first developed by the Greeks. So, and a lot of things, there's so many different things that interacted in the ancient world, more so than we realize, that ends up giving us a tremendous amount of the mathematics that we know now. Yeah. Look at all this good stuff. So many different things that come to us from India, from Europe, what have you. Again, decidedly not all Western. Decidedly not all European. The Islamic Empire. So the Islamic Middle Ages, 632 to 1258. Ended around the time of the Crusades. In here was when, Crusades and a little bit after, was when that period really ended in that area of the world in the Middle East. The Islamic Empire made significant contributions to math since the 8th century. Over time, Muslim artists discovered all types of symmetry that can be done on a 2D surface. You remember the video on the origins of the scientific method? One of the things that happened during this time was empiricism, the development of empiricism by one of the many Arabic scientists and mathematicians that existed, that lived back that time. And so that was one of the things that got brought into Europe. Something that already existed very much so in the Middle East. In the Middle East was all of that knowledge that got brought back as part of the Crusades. So this is the thing, is that it really did come a lot from Arab and from the Arabic countries and the Arabic world, with the different kinds of things associated with math and science that we now think of. Refined and improved upon, perhaps, in Western tradition, but originally in its origins, not from Europe. In here, not from Europe at all. And it's a thing to remember, these kinds of things, and to know your own full and complete history of where these kinds of things come from, right? The Renaissance of the 16th century, the Renaissance of the 17th century. An important person in the early 16th century was the Italian Franciscan friar named Luca Pacioli. Multiplication, division, decimals, and inequality symbols were more recognized in that century. The invention of the logarithm in the early 17th century, John Napier. French mathematician Girard Descartes, I cannot pronounce it, considered the founder of a field of perspective. France became more prominent toward the end of the century. Lagrange worked with Euler to joint work on the calculus of variation. So you're getting your advances of calculus and algebra and what have you. Let's see. 19th century math. Argonne posted a paper on complex numbers and how how complex numbers can be shown in geometric diagrams. George Peacock is usually credited with the invention of symbolic algebra. Abstract math in the 1800s. Abstract math is a branch of math concerned with the general algebraic structure of various sets. Definitive treatise, Modern Algebra, was written by Bartel van der Weerden. Again, pronunciation that I just butchered. And it impacted all branches of math. So things like this came to be in the 1800s, at least in their written form as we know it now. But as I was saying before, there is plenty of evidence of some of the older world having the ability to do algebra and quadratics and the like. So don't forget that. 20th century. In the early 20th century, there was the beginnings of the rise of a field of mathematical logic. Hilbert was responsible for several theorems and some entirely new mathematical concepts. 21st century math. Here in the present, we learn from our history and then discover new branches of math. So that is the short version of the history of math. And there's actually a lot more good stuff in here. I actually find the story of mathematics here to be a nice, longer summary of it. Not perfect, of course. There's some details I think that got left out in here from some of the things, and probably some details that I left out. But the point today was not to walk through in full gory detail the fullness of math that exists, the fullness of the history of math. Yep, Islamic Empire, to draw on, yep. But you can get into a lot more detail and depth in here in the history of math. And I encourage that, because the thing is, with all the stuff that's been going on, there is a perception that mathematics as a discipline is, it's attacked as white, Western, exclusive, we can't teach people that way, all this kind of stuff. And it's disappointing because these people who are doing that clearly do not know. Well, I don't know that they don't know. I'm going to say that they may know, but they may not know. But the thing is, I think a relevant thing of if you're teaching math, you probably should know some of the history of mathematics and recognize that it is not entirely Western. It is certainly not Western in its great origins, all the way back into the history of the ancient world. And like so many of the things that we have now, be it the scientific method, be it so many other different things. And actually now the Arabic numerals come to us from the Middle East. So like the number form, the number symbols that we use now for the numbers, like the 1 and the 6 here, those are drawn from Arabic. They're not the Roman numerals. Those are the Arabic numerals, I think. That's not the right name for them, I don't think, but I can't remember the name right now. And so we got to remember the history of all these different things goes back to the very beginning. And the thing that I find fascinating that's getting forgotten is that the history that we have here, all of these sciences and fields that we've gotten into, they all have their roots from somewhere, They all have their roots from somewhere. They all have their roots from somewhere much older in the world than just Europe. Now, I give you credit. A lot of what modern mathematics does come from Europe. And such is the case. But that is not the roots of mathematics. And the idea here that it is purely and only a Western thing is wrong, because you can actually see in the history that so many different cultures, so many different places around the world had very much the concepts of math, modern math that we know, before they could have ever interacted with with a Western culture, or with Europe, or with what would become modern day Europe. So, I question that thing of forgetting the longer history, and just focusing on the more recent history, and more recent history being the last 200, 500 years, when there's thousands of years of history on this planet now. So that's the thing. So that's your brief history of math. I hope you enjoyed it. I hope you pop over to Locals and join us. If you like this video, hit the like button on the way out the door. Comment on the video, share the video, subscribe to the channel, all that lovely jazz. Until next time, I'm Adrian, and I hope you stay curious.